All right, folks, we're starting our next unit, which is on similarity, more specifically on similar polygons. Hopefully you're noticing on these two pictures up here that we have a rhombus, two rhombuses on this side, but they're different sizes. Same thing over here, we have a quadrilateral that are the same, but they're different sizes. So that's what similar figures are. They're the same shape, but they're different sizes. Two things need to be met in order for them to be similar. That would be that our corresponding angles are congruent. So angles that are in matching spots are the exact same measure. And the corresponding sides are proportional. So again, that would be matching sides are proportional. And proportional means that they're either shrunk or enlarged by the same scale factor. So you're going to see that we're going to either multiply our sides by a number to make our shape bigger or smaller, and that number, that ratio, is called the scale factor. And then we'll talk more about this tomorrow, but if polygons are similar, then their perimeters are proportional. Or their perimeters are proportional. Okay, so let's just look at this first example here. We're told that we have similar figures, and it's our job to list their corresponding pieces. So if we look here, angle A has one arcing mark. That matches angle W, so that would be angle W. And if we go to angle B, two arcing marks, that would match angle X. I really wish my colors were working. I'll try one more time here. Angle C, nope, still not working. That's right, matches angle Y. And then lastly, angle D matches angle Z. Perfect. So our angles have to be the exact same. Now we're going to look at our sides. So if I look here, AB matches WX. And we'll just work our way around. BC matches XY. CD matches ZY, and then DA lastly matches WX. So when it is, WZ, it's kind of confusing when you just look at the letters, but if you notice, all of our sides have a side length. And that's how we figure out that ratio, that scale factor. So if we pick one of our sides from our bigger polygon, let's just do AB, the top one, 15. 15 corresponds to 5. Now we always want to reduce. 15 over 5 reduces to 3 over 1, or just 3. So if you notice, that works for all of our sides. If I take 4 times 3, I get 12. If I take 7 times 3, I get 21. If I take 6 times 3, I get 18. Or you can go the other way. 15 divided by 3 is 5. 12 divided by 3 is 4, and so on. So that's what that scale factor. It's pretty important, and we'll get to that later on. And then lastly, our similarity statements. We just list our vertices, and then write the similar, which is that little squiggle right there. And now we match. So A matched W, X, Y, Z. All right, let's try another one. Let's look at these triangles here. We're told that they are similar because we have this similarity statement. I like using that more so in the picture because sometimes I get lost since they're different sizes, and sometimes I rotate them on you or reflect them, so it's just easier for me to look at my similarity statement. But if I look at my angles, we just go in order. Angle F is the first letter, matches angle J. Now I'll go to my middle letters. Angle G is congruent to angle K. And then our last pair of angles, angle H, is congruent to angle L. Now we're going to look at our corresponding sides. Pick my first two letters, FG matches JK, and we want that ratio to be the same as GH over KL. And we want that to also be the same as our last pair of sides, H over JL. And I just use my similarity statement up here to help me write my corresponding parts. I don't think we need to do this again, so I'm going to skip this next one. The 2 examples of listing is plenty. Okay, so let's see this in action. So right now we have just 2 figures, and it's our job to figure out if they're similar. If so, we got to write a similarity statement and their scale factor. So remember, there's 2 things that need to be true for polygons to be similar. The first is our angles need to be congruent, so I always like to start with my angles because they're the easiest to check. So I give myself a little thing that I'm checking my angles. If I look here, and I look to see if they all have a buddy. I look, angle A is 59 degrees. Does that match anything on my smaller triangle? Yep, it matches angle B. Now I'm told angle C is 35 degrees. Does that match anything? It sure does. It matches angle F. Now we don't know what angle B and E are as of right now. We could find it by subtracting, but based on our previous knowledge, if 2 angles of a triangle are congruent to 2 angles of a different triangle, then their third angles are congruent by default. Remember, that's that third angles theorem. So we do, in fact, have congruent angles. So I'm going to put a check mark, put a star or a smiley face, just some kind of indication that you checked your angles and it worked. Now we're going to go through and look at our sides. Now we want each pair of matching sides to be the same scale factor, the same ratio to reduce. Now, since it's not giving us an order to do this, I always like to start with my smallest side on my smallest figure. So if I look here, my smallest side on this triangle here is 4. I'm going to put 4 on top. And now what does that match? Well, that matches 6 on my bigger triangle. And we always want to reduce, so 4 over 6 reduces to 2/3. So that's what we're looking for on our other 2 pairs of sides. If we don't get 2/3, then they're not similar. All right, now we check my medium sides. My medium side over here is 6. My medium side over here is 9. 6 over 9 does also reduce to 2/3. So far, means you're looking okay. These guys match, so it's going all right. Now our last pair are big sides, 7 over 10.5. Now, we're not supposed to have decimals in a fraction, so if you're kind of freaking out about how to reduce this, it's okay. If you ever have half of something, right, I would just double it. Double the top and bottom. It keeps the ratio the same, but we'll get rid of our fractions. So 2 times 7 is 14. 10.5 times 2 is 21. And now we can reduce that. Hopefully you're seeing that 7 goes both into 14 and 21, so 14 divided by 7 is 2. 21 divided by 7 is 3. So, we notice we have a bunch of 2/3, so they all have the same ratio, which means that they are, in fact, similar. So our scale factor is 2 over 3, or you could put 3 over 2, because it didn't specify the order, so we're at liberty to do what we want. And then over here, we got to write triangle. I'm going to do ABC. Is similar to triangle. Now I gotta look and see what matches with A. A match D, B, and E. Okay, so D, E, F. D, E, F. Perfect. Alright, let's try another one. So again, we need to check our angles first because it's the easiest thing to do. Because once it's no, we don't have to keep going on with the process. We're just done if it's no. So I gotta look. Angle S matches angle Z, angle R, Y, angle Q, X, and P, and W. All right, our angles work out. They're checked. We're moving on to part 2. Our sides. Well, if we look here, folks, we only have the rhombuses, right? There's only 2 different numbers. So I'm going to put my smaller one on top, so 3 over 7.5. We get that pesky decimal again. That's okay. I'm going to multiply by 2. 3 times 2 is 6. 7.5 times 2 is 15. I notice that 3 goes into both of those, so 6 divided by 3 is 2. 15 divided by 3 is 5. So there's our scale factor. So our scale factor, 2 over 5, or 5 over 2, doesn't matter. Now I'm going to write SPQR, I believe, was the order of that. Let me just double check. SPQR, perfect. And that matches ZWXY. ZWXY. All right, let's introduce a little bit of algebra into this. So we're told we have similar figures. Here's our similarity statement. And now we're looking for missing side lengths, missing values, right? Let's start with the easy one. Let's start with x. So I really wish my colors worked, but that's okay. Okay, there we go. We'll use red's fine. Okay. So x right there. FD matches YZ. 10. So that's my first ratio. Now I want to set that ratio equal to two sides that I know something about. So I have to avoid using this side here, because I can't have another variable in my equation, because that's not going to help me solve it. So we want to use what 6 is similar to, or what that matches. So YW matches CD. And now the tricky part is, folks, you have to go in the same order. So since I put X on top, I have to make sure I put 9 on top. I have to keep my order the same. So 9 over 6. And now we can cross multiply. And if you're kind of confused what I'm talking about, you maybe learned this in like 7th grade, but you cross multiply. So I'm going to take 6 times X and set that equal to 9 times 10. And now we just solve like normal. 6 times x is 6x. 9 times 10 is 90. Divide by 6. We get x is equal to 15. Perfect. Okay, let's try that again now with y. So I like to start with my variable because that just makes the most sense to my brain. So I'm going to have 3y minus 1 over VZ, my first and last two letters, match AF, so that's 12. So I'm going to put that over 12 and set that equal to, now I always like to use the sides that we were given, like the freebies, which was 9 and 6. We didn't do any calculating, that was part of the problem, that's like your free stuff. But now you got to be careful, since I started with 3y minus 1, I have to start with 6 on top. You got to keep it the same. The order does matter. And now it's the same thing, folks. We're going to cross multiply. Be careful, though. You're going to have to distribute that 9 to both the 3y and the negative 1. 6 times 12. All right, here we go. 9 times 3y, 27y. 9 times negative 1 is negative 9. 6 times 12 is 72. Add over our 9. Divide by 27, and we should get 3. Perfect. Kind of confusing, but the more we do, the more it will make sense. So let's try it one more time just to maybe hit it home. So same thing here. We have two similar polygons, two similar triangles, I should say, and we're looking for x and y. I'm going to start by finding x, so I'm looking here. LM matches ST. So I'm going to put 6x minus 3 over 3. And I'm going to set that equal to, well, I don't want to use JL because there's a variable there, so I'm going to use 4. So JM matches QT, which is 2. And remember, since I started with this triangle, the 6x minus 3, I have to make sure I put 4 on top. I have to keep the order the same. And now we just do our cross multiplication. Make sure you distribute that 2. All right, so we'll get 2 times 6x, which is 12x, minus 6 equals 12. Add over our 6, we get 18. Divide by 12. It's okay, we're going to get a decimal. That happens in life. Not everything's even. There we go. All right, and then our last one here, we're looking for y. So I noticed that JL matches QS, which is 5. So 3y minus 2 over 5 is equal to, now it's your choice. You could, again, use whatever sides you want since you know what the value of the x is, but I just like to keep it simple. I'm going to use the sides that just were given to me, which is 4 and 2. Again, since I started with this triangle, I have to put 4 on top. So 4 over 2. And now we just do our cross multiplication. So 2 times 3y minus 2 equals 4 times 5. Distribute 6y minus 4 equals 20. Add over the 4. Y equals 4. Perfect. All right, folks, we'll finish notes tomorrow. Thank you for watching, and have a super rest of your day.